This presentation will deconstruct the Georgia Standards of Excellence for 3rd grade Math 3 MBT 2, which states that students will fluently add and subtract within 1,000 using strategies and algorithms based on place value understanding, properties of operations, and/or the relationship between addition and subtraction. As students transition from 2nd grade to 3rd grade, the scope of numbers that students use does not change. But the level of understanding transitions from more concrete, hands-on models to more abstract application of strategies using a strong understanding of place value, the properties of operations, and the relationship between addition and subtraction. Teachers should transition their instruction from 2nd grade to 3rd grade by using the concrete, representational, and abstract approach. The foundation for adding and subtracting multi-digit numbers begins with 3D hands-on models that are concrete and easily regroupable. Students then progress to computing addition and subtraction problems through 2D representations or pictorial models. Place value disk and drawings of base 10 models help students transition from hands-on to abstract computation with numbers and symbols. This transition occurs once a deep understanding of number sense has been developed. As students are exposed to composing and decomposing numbers in different ways, they are then able to apply that understanding to more abstract representations and understanding that is required with regroupings. 100, 2 tens, and 4 ones is the same as 12 tens and 4 ones, as well as 11 tens and 14 ones. With a strong foundation in number sense and flexible thinking, 3rd grade students then move to more abstract applications without models. They may represent and explain their thinking in a variety of ways. Teachers should guide students through a wide variety of methods for solving addition and subtraction problems. While the correct answer is important, students need to feel comfortable in solving the problem in a way that makes the most sense to them, while also having knowledge and practice with other strategies as well. While Student 1 added by decomposing the numbers, Student 2 used compensation to make friendly numbers. Student 3 and 4 then added up in chunks. Students transition to the standard algorithm in 4th grade. Introducing the algorithm too early can unfortunately lead to many common misconceptions.
There are several common misconceptions that students acquire with addition and subtraction. For the first misconception, students need to understand the position of numbers using place value. Using a place value chart or grid to line up their numbers will help them to form a visual reminder of each place value location. In the second example, pupils may subtract the smaller digit in a column from the larger digit, regardless of which appears in the top line. This can arise if they hear, for subtraction, you always start with the bigger number and subtract the smaller number. Again, using place value grids alongside the solving calculation will help to address this problem. It allows pupils to concretely regroup 10 ones as a 10 and move it to the tens column or 10 tens as a 100. When they can count the disks or blocks to calculate the total, they will see that they include the quantity that they have regrouped. This example shows that the pupil is not thinking about the calculation as a whole, but treating each column as a separate subtraction in its own right. The pupil needs to work on their understanding that numbers can be partitioned in different ways. For this third misconception, it demonstrates why it's vital we do not rush into the abstract recording when teaching the column or traditional method for subtraction. Pupils must use blocks and disks and place value grids to concretely experience the regrouping process in subtraction in order to develop a secure conceptual understanding before recording it in its most abstract form. Expose the pupils to the abstract alongside them, carrying out the regrouping process concretely. For this last misconception, these type of errors illustrate that the pupils need to develop their understanding of 0 as a placeholder. In this example, they have perceived the 0 to represent 10 and tried to regroup it, seeing it as 10 ones, only one of which they have moved to the ones column. They need to see that the 0 means that the 0 tens are present to realize they need to move on to the hundreds column and regrouping 100 as 10 tens.
I write 300 and plus 60 plus 8 and 400 plus 50 plus 7. I know that 300 plus 400 equals 700 and 6 tens plus 5 tens equals 11 tens and 8 plus 7 equals 15. So I add 700 plus 100 and it equals 800. Now I have to add 10 plus 10 equals 20, and I know that's a 5, so I write a 5 here. And the total is 825.
I can use a number line to find the difference. I start at 345 and count all my hops, the tens, the ones, and the hundreds to get to 512. My difference is now 167.
Question was 93 minus 65. I wanted this to get to a number that I could subtract this easily. So I added 2, that got me to 95. I subtracted 65, that got me to 30. I subtracted the 2 I used up here, that got me to 28. 37 plus 58 in it, and then I added 2 to 58 to get it to a family number, and it gave me 60, and then I came over here and then I subtracted 2 to 37, and then it gave me 35, then I added 35 plus 60, and it gave me 95. Almost 373 plus 256. I started with 373 because it was bigger, and I added 200 from the 256, and I got 573. And then I added 50 from the 510s, and that got me to 623. And then I added 6 more, and then it got me to 629.
After teaching all the strategies, students can then use their new knowledge of addition and subtraction strategies to complete a variety of tasks. The next few tasks are examples from the Georgia frameworks of some great ideas to help students show what they know. This first task is called Let's Think About Addition and Subtraction. Students solve word problems using their chosen strategy. In the first picture, the student chose to use the picture method and the break apart or place value method to prove she would end up with the same answer both ways. In the second example, the students were able to use trial and error to discover one of the many combinations of treats bought using $10. This next task is a 3-act task. In this task, students will view a video and tell what they noticed. Next, they will be asked to discuss what they wonder about or are curious about. Students will then use mathematics to answer their own questions. The first chart was completed whole group, and students were dictating from their individual work. The second chart was just 4 different ways the students chose to solve the problem. This slide shows the students hard at work grappling with the information from the piggy bank task, answering the main question of how many coins did she have in all. The top picture of 100 plus 10 plus 5 was a student who had finished the original question of how many coins early. So she started trying to solve another question. How much money did she have in nickels? This last task provides an opportunity for students to decompose numbers in multiple ways. This will help them easily manipulate numbers as needed in computation, as well as understanding the value of digits and numbers when rounding. The students first placed war in groups of 4. Then they took their winnings and glued them in order from the smallest quantity to the largest quantity, having to decompose and manipulate numbers.
There's 470 pennies.
Wow, that was $4.70.
How do you know that's $4.70, Garrett?
100 pennies makes
The implementation of tasks and strategies throughout 3rd grade helps students become more fluent while developing a deeper foundation of number sense when adding and subtracting larger numbers. To go beyond the surface of procedural fluency, tasks such as this open middle activity can challenge students who are fluent with a variety of strategies to engage in critical thinking and productive struggle. Implementing tasks such as this provides a rigor and depth that is needed before moving on to the traditional algorithm.